Alrighty, so today we're going to be looking at the Save Scooby challenge from crackmesh.one, and let's go ahead and open up our notes.txt file here just so we can stay some. Oh, it looks like I already have it opened up. Anyways, alright, so Save Scooby. And something that I kind of failed to mention in the past few challenges, it's always good to have like a goal. And even though for these challenges the goal is always going to be pretty straightforward, right? Either do a keygen, find a flag, but it's always good just to have a goal kind of written down somewhere, just so you know whether or not you're moving towards achieving that goal or not. And so let's go ahead and look at the description here, and the goal here, they say to write a keygen. So that's our goal, write a keygen. And we also have some constraints here. So constraints are no decompiling and no patching. All right, so we never decompiled yet anyway, so we don't have to worry about that. And we also haven't patched, so don't have to worry about those two constraints, but just know that they are there. And let's begin. So I always have to run file on the binaries when I first get them. So save Scooby, and let's see here, normal stuff, 64 bits, elf, all that good stuff. And we see that it's not stripped. I always like to see that, so I can go ahead and look at the symbols. And let's see if anything jumps out at us. Let's see here. That's kind of interesting. You don't often see git current working directories. I'll just list that down there. We got scanf there going on, so of course we're going to be accepting our user input there. We got the main function there. All right, string length. Nothing too crazy, but still some good things just to take note and to look out for. Go ahead and run strings. And let's see what else we can find here. So this here looks like it's going to be the failed message, not too easy. All right, so let's go ahead and jot that down. And right above it looks like it's the success message there. So go ahead and jot that down also. And this here is the prompt. I won't copy that down, it's not important. Let's see, and that's pretty much it. So I'm gonna try something crazy, and I'm almost certain this won't work, but I'm gonna try everything kind of, guys. So we know that we're using the git current working directory function. This, like I said, it isn't gonna work, but you never know. Sometimes they do some crazy stuff. Like I said, path of least resistance first. Try the obvious thing. Let's just see if that's gonna work. All right, no, of course not. That's fine. So let's go ahead and open this up in IDA Pro. And yes, I'm using IDA Pro this time. Someone convinced me I should try it out. And so here we are. And go ahead and hit new. And hit save Scooby. And oh, that's good. Hit OK. And let's see. All right, good. All right, so here's IDA Pro here. Let me go ahead and track this out there. Yep, and so right now I'm going to create a sudo.c file, and I'm doing this because I'm going to be writing out like I'm going to be trying to translate the assembly to C like code. Don't try to compile it because it won't compile, but it'll look like C. And I do that just so we can get the color, the colorized stuffs, all that good stuff. So that's why I ended .c. Anyways, so first things first, you see that it's getting this, they call it buffer, and that's pretty nice. It's actually a useful variable name. That's pretty cool. In Ghidra, everything is more like this, but anyways, I won't try not to compare Ghidra and IDA. That's not what this video is for. Anyways, so you see that we're loading the buffer into RAX, and then we load this big size into ESI, and then we call it git current working directory. So I'm gonna assume that this is the CWD, and that's what it is. So I'm going to press the N key on my keyboard, and that's how you, in IDA, that's how you do the renaming of variables. So I'm going to call this CWD. Oh, this thing is telling on me. Why is it showing my history there? All right, so yeah, as you can see, I've done this before. So I better get it right? Okay. All right, and so let's see, and then you see that we have string length here, and it's assigning it to this variable here. So this guy here is the string length. So cwd len is equal to what is that? Sterling CWD. And so just as like a reminder, we had this for our CWD, and the size is 51, and I already did it before. It's 51. Trust me. You can calculate it yourself, but it's 51. All right, just trust me. And all right, and so then we move on to this guy here. It's getting assigned a value of 0, and I'm pretty sure this is going to be like some loop control variable. So if we go jump to this location, we see that it's comparing this variable to the length of the CWD. And then if it's less than, you see that it jumps up here and it does some stuff. And I'm going to jump back down there, and you see that up here it's adding 1 to that variable. So that looks like a loop, right? So I'm going to go ahead. I'm going to rename this variable here to I, and then I'm going to say I equals 0, and then while I is less than CWD len, we're gonna be doing some things. All right, so, and first things first, we see that it uses I and assigns it to this EWX variable, or not register, sorry about that. And so down here, it uses this CDQE instruction. I forgot what it stands for, but all that is doing is just taking this 32-bit register, which is EAX, and it's extending it to a 64-bit register. So essentially to be something like this. So right now I holds a value of 0, so I'm not going to type 32 zeros in there, but just pretend it's 32 zeros. So I'll just say pretend 32 zeros in there. All right, so that's what EAX holds like that, right? And so then this CDQE command is going to come in and say, all right, so to extend it to 64 bits, so just pretend that's 64 zeros. And essentially so it can fit into the REX register, right? And so that's all it's doing. So, it's not a crazy instruction. It just kind of threw me off for a while, but yeah, that's all it's doing. And you see here it's using REX, and we see that the current working directory variable there. And all that is pretty much saying CWD sub I. That's all that really is. So if you notice, if you go back up here, it's loading the entire actual variable into the memory. Here we're just moving one pretty much byte into this EAX register, and then you see that we compare it to so that's going to be if, and we see that we're comparing it to 0 hex. I didn't mean to do that. 0 hex, what's that, 2F. And what's nice about IDA, I like this because it actually shows what the value is without, in Ghidra you have to like hover over it, but it's just showing 2F as a slash characters. That's really nice. I like that. And so then, all right, so you see that it compares it to 2F, and so I'm just gonna say if it's equal to this, then we're gonna do CWD sub I is $. Yeah, $. And so, okay, so where did I get that from? Well, so here is the comparison happens here, and J and Z means jump if it's not 0, and if these two are equal to 0, it's going to be 0. So essentially, if these two are equal, it'll execute this. So you see that it's assigning $sign to CWD sub I. If it's not 0, then we're going to do some other stuff. So this is going to be our else statement here. So else, we're going to do other stuff. And I cannot spell, but you know what that says, other stuff. All right. And let's see what this other stuff is. And this is kind of where it gets a little bit confusing, at least for me, because I was trying to wrap my head around how I can explain the loop or these control structures. There's going to be some if ors and if ands and all that stuff, but I was trying to see how I can explain it. And I think I got a pretty good grasp of it. And I'm going to show you guys the graph view of this, because I think it's a little bit easier to kind of see it this way. So I'm just going to change to the graph view here, and you do that by pressing the space bar, and you see now we have the graph view. And this is pretty cool because it'll, if we jump here, we say, okay, we can do that, and it jumps to this block of code, and then we say, okay, if this is not 0, then it can jump down here. And it does animate too, I think. So if I jump to like something that's down there, you see it moves. So pretty cool. But anyway, let me move that over here. And so So now we're in the else statement, right? So this is the else statement that we just kind of came to. Like if it's not 2f, it's going to come down to this statement here. And you see that we are again doing some comparisons. So we got if CWD sub I is, and that says it's less than or equal to hex 60. All right, then we're going to go down this block of code here. But you see there's another comparison that happens, and that also leads to the same block of code, which is this block here. And so that's how like if the OR statements look like. So like if this happens, you know, if this is true, we don't have to check this one at all because we can just jump to this block of code that we're interested in. If it's not true, then we have to check this one. All right, so if one of these two are true, so if CWD is less than or equal to 60, or CWD sub I is greater than hex 7a, then we jump down to this block of code here. We're going to do some stuff, and I'm going to come back to this in a second. So what happens if if both these statements are false? So if this is false here, this is false here, you see that I can follow this red line here, and it comes, oh, that's not where we're supposed to go. It comes here. What was that about? Oh, all right. Anyway, sorry about that. So I don't. This is my first time using it, really. All right, so just bear with me if I make some silly mistakes. Anyways, so we see it comes to this block of code here, which you see we take CWD, we store it. So I'm gonna just say else here. So we're gonna take. Actually, let me bring this over here. Sorry about this, guys. Growing pains. All right. Okay. So we got EAX, and we set that to CWD sub I, right? And we see we're going to do essentially EAX minus equals 0 hex 1E. And then we see that EDX equals EAX, right? And then we say EAX back equal to I, and we do CWD sub I equals to DL. So all that is to say, very simply, all that craziness just does CWD sub I minus equals. That's it. That's all it is. So sorry for kind of getting, I like to just kind of show everything how it works. So that's all that's saying right there. So that's that. So now let's get back to this statement here, this doing stuff. And actually, and then after this happens, you see it adds 1. So I'm just going to go ahead and, before I forget that, so right here, so after it does this, you see it jumps to 81C, just adds 1 to I. So I plus plus, and that's it. All right, so back up to here. And let's see. Oh, wait. Yeah, okay, great. Okay, sorry about that. All right, so back up to this place here. So we have another if statement, and this is kind of where it got a little bit confusing to me, because usually when I see like if this and that, it looks a little bit different, but hopefully after I go through everything, it'll make sense. So we have this first if statement here. So we're just saying if CWD sub I is less than or equal to hex 40, right? So we got that in there. Okay. And then it's comparing this statement here. So not if, I'm just going to do like another thing right here. CWD sub I greater than hex 7a. All right. So, but the problem here is that if it's greater than hex 7a, it actually goes to this block of code here. And we want to get to this section here. We want to do something with this, because otherwise this will never get used. So, and it's kind of weird that this is in a red, but maybe it's inverted, I don't know. But like, we want to actually kind of go through here so we can get to here, right? And so the only way we can get to here is if CWD sub I is actually greater than hex 40. So we're gonna have to change this to greater than hex 40, right? Because that'll get us to this comparison here. And if this comparison for us to get to here, see if CWD sub I is greater than hex 5A, we jump to this block of code here that we don't want to execute, right? So we want to get to this block of code here. So this, we're going to have to invert this yet again. I apologize. Move this over. We're going to invert this again, and we're going to say less than or equal to hex. Oops, sorry about that. Should be 5A. Not bad. 5A, right? And so then that'll bring us here, which if you notice is pretty much the exact same thing. It's going to be CWD sub I plus equals 0 hex 1E. And that's pretty much it. That's all there is to this. So I hope that kind of makes sense how I kind of broke this down. And so now I'm gonna kind of explain what this actually is doing. So it's kind of interesting what's going on here. So we first got if it's what is that? If CWD sub I is a slash, then set CWD sub I to $, right? So we got that part. Then else we got if it's alphabetic, and I'm gonna get to why I say it's alphabetic, and it's uppercase, then we add 1E. Else alphabetic. Man, did I even spell it right the first time? Okay, I think I did. Lowercase, then we subtract this, right? This should be else if there. Sorry about that, guys. And then finally, if it's anything else, then we don't really do anything. We kind of just, it's pretty much like a pass, right? So let's go ahead and let me break this down for you real quick. So, and shout out to my viewer. He actually, the same guy who told me about I should use IDA Pro. He told me I can do this. Give me the ASCII characters, the ASCII table. Whereas if you can remember my past video, I actually went to Google and typed in the ASCII table, all that nonsense. But this it's right there, and it's pretty beautiful. I love it. All right, so let's go ahead and let me demonstrate the fact that if it's a non-alphabetic character, that it's just gonna pass this into none of this is gonna be true, and it's gonna pass this up. So let's say our character is this one right here, the closing bracket, which is hex 5D, right? So obviously it's not equal to 2F, so it's going to come here. So it's hex 5D, and I guess I'll write it in here. Is that less than or equal to 60? Yes, it is. So we're going to go in, we're going to do and check this. Is hex 5D, is it greater than hex 40? Yes, it is. Sorry. Is it also less than or equal to hex 5A? No, it's not. So it's just going to come out here and add 1 and go to the next character. And so and it's similar like that for the other ones as well. For the other characters, similar things will happen. Like it may pass one of these checks, but it won't pass both of these. It won't pass both of these, right? So that's why we have the and here, because it has to pass both of these in order for us to get to this section here. And you can look at it for like the other characters. So if it was like A through Z, it's gonna come up here, and if it's A through Z lowercase, it'll come down here. So all right, so we got that. So now let's go ahead and write the keygen. All right, and so you guys remember I'm not the best programmer, so don't make fun of me. And also, if I make a mistake, let me know. Don't just let me look stupid like last time. All right, come on, tell me I'm messing up. Don't just, okay, I know you can't tell me. All right, I'm messing with you. All right, so equals to that. But if I do mess up, it's your fault, just so you know. And we're gonna create a function called encrypt, like that. And we're gonna do this. And actually, another viewer mentioned another tool called CyberChef. I wanted to use that here, but I wasn't entirely sure exactly how to use it for this use case. I'm not too familiar with how CyberChef works, but it's a really cool tool. I'll link that in the description below in case you want to play around with it. It's really cool. One day, hopefully, I will add that to my repertoire, but not today. Then we do this, right, slash, then we got Scooby plus equals $, else if X is alpha. See that? I almost, yeah, same thing, like just like last time. upper. We're gonna do what? What is this? Scooby plus equals this plus 1e. Elif is alpha. Jesus. And lower is lower. So yeah, I'm just the worst at this sometimes, I'm telling you. Subtract e. Else, we're going to just put that on there, and let's print out Scooby at the end. All right, so hopefully I didn't make any mistakes. Like I said, if I did, it's your fault. All right, and I didn't mess up this time. All right, good. All right, so let's go ahead and copy this, and this should work. This should be what they were looking for. It'd be nice if I copy the entire thing, right? So copy, save, and there we go. All right, and that's pretty much it. That's our keygen there. But let me show you something that's gonna piss you off, because it pissed me off. And excuse my language there, but I'm telling you, I was peeved when this happened. Watch this. Look at this. You watching? Watch this. Like, if okay, the reason why I'm pissed off, we just went through all this work, and granted, it's not tough work, I get it, but we did all this nonsense. We created the keygen, right? We did our little pseudo C to see what they're doing. We looked at this in IDA. We looked at all those pretty graphs and even the little text view stuff. We did all of this stuff, and yet, all right, sorry. So let me calm down. Let's go back and let's look at the rest of the code, and let's see what's going on here. And I'm not sure if this is a mistake of the actual programmer, if he meant to do this, or if this was an accident. But anyways, let's go ahead and let's keep it going. So we stopped pretty much right here. And so then we're gonna continue on. So we see this is where they're printing out our prompt there. And we see here, so let's go back to our, what is this? Our pseudo C. We're gonna add on to this. And right here is where they're going to do the scanf function here. So this is going to be our user input, because you see that's loading to REX. You know, I mean, I showed you this in the press video before, so I'm sure you recognize that there. So that's our user input right there. All right, and so let me write that down. Scanf %s user input. And so just as a reminder, this is our user input right here. And then we do string length of our user input, which is, what did I say, user? Ooh, I named it something different last time. I don't know what I named it last time, but it was something different, obviously. Equals this. And of course, this is just going to be 1, right? All right, and so one of these guys is going to be 0, or sorry, it's going to be like another, like a, not necessarily a loop control variable, but it's going to be used in the loop. And so let's go ahead and see which one is used, and var 8. All right, so I'm going to go ahead and go back up, and I'm going to call this guy here J. And this guy here, you know me, I don't really know what it's doing yet, so I'm going to call it is what it is. So we got, what happened here? Oh, J equals 0 and is equals 0. All right, and I'll show you why I believe this is a while true type of loop. I'll show you in a second, but let me just show you what's happening in the loop first. And so I know that's kind of backwards, and I apologize, but I think it'll make more sense if I do it this way. All right, so we jump here after we set those two values equal to 0, and the first thing we do is we see that we compare if J is less than or equal to user input, if I can spell it right, then we're going to jump to, oh sorry, greater than or equal to, my bad, sorry guys, I'm sorry. All right, so it's greater than or equal to user input length, and we jump to this block of code here. And if you notice, this block of code is going to be the one that does a check, and then we can possibly win, you know, we can win the medal here. So this is the code that we want to get to. So we want to get to this block of code here. But let's continue. If it's less than or equal to, or sorry, less than user input length, it's gonna then compare J, is it less than CWD sublen? But if you notice, if it's less than that, it's gonna jump up to, and it's gonna jump up here. So what does that mean? If it's greater than or equal to, and I'm gonna say, or if it's greater than or equal to CWD len, then we simply go to location, what is that, 8B2, right? So if it's greater than or equal to, then it'll jump here to where we can possibly win, and we that's what we want to get to. So it's pretty obvious this time. Oh, sorry, go to, and I'm just gonna define this here, 8B2, like that. All right, stuff. Okay, and let's see. So let's go ahead and continue with the loop here. So you see that it jumps up here, right? And so then we're still in this loop. We're going to compare. We're getting CWD, this time it's sub J, right? So we got CWD sub J. So we're going to do some with that. And we also see that's also user input sub J. So user input sub J. And then we do a comparison right here. And if these two are not equal, then we're going to jump to this block of code here. And this is kind of why I say I think this is a while true type of loop, because if you notice, and I just kind of said it's going to break out of this loop if they're not equal. And that's the only time this is ever going to break out of the loop, because, so say if these two were equal, then it adds 1 to J. So I'll just go ahead and add that in here. J plus plus, it adds 1 to J, and then it jumps back here. And there's never ever a point where it's like J is, if it's less than, user input, then we break out of the loop. It's always, I guess technically this, but that's more of a go-to. That doesn't really count. But J isn't really being used to, I guess, break out of the loop. If that makes sense. So that's why I think it's just like, it's while something is true, just keep doing these series of commands. All right, so we're pretty much there, and you can probably already see it right now. So if this is, see why like that whole thing worked, like why we can just type in $, and if you can't, it'll become apparent right away. And so like I said, it breaks. And you see once, let's see, where is it at? If it breaks, you see that we get to this block of code here, which it will set is 0 equal to -1, right? And then it jumps to location 8B2, and in 8B2, if is 0 equals to 0, I'm just gonna say success, else failed, right? So you might already be able to see why we can only, if we just type in a $, it works. But if you can't see that yet, let me just show you real quick, because this is longer than what I wanted it to be, and I apologize. All right, so we got initially J is going to be 0 and user input is going to be 1, because we just typed in $. So it's going to come here, it's going to check that is 0 greater than or equal to 1. No, it's not. So it's going to check is 0 greater than or equal to 51. No, it's not. So then it's going to check is CWD sub I, oh sorry, that should be sub J, sorry about that. Is CWD sub J, is it not equal to user input sub J? And they are going to be equal to each other, right? Because we know that the algorithm is going to set the first character, because it's going to be a slash, since it's a directory, it's going to set that character to a $. We know that. So this is going to be true, or it's going to be false. So it won't break out of the loop. It's going to add 1. So then it's going to come here and check. Is 1 greater than or equal to user input? Yes, it is. So then it jumps to location 8B2. And you see that we skipped this whole part where it sets it equal to -1. And so it's still equal to 0. Is 0 equal to 0? Yes, success. And that's it. And that's why it works, right? And so it's pretty easy once you kind of break it down like that. And so now that's pretty much it for this video. So I guess to recap really quickly, because like I said, it's way longer than I wanted it to be. We were able to analyze their algorithm. We figured out that if it's alpha beta character and it's uppercase, it's going to add hex 1e. If it's lowercase, it's going to subtract. And if it's not alpha beta character, it's going to pass it. And it changes all slashes to $. We wrote a little keygen. We did that. We verified that it works. Then we saw this nonsense that said, well, you know, kind of slap in the face. You didn't need to do all that nonsense anyways, but we did it anyways. All right. So that's all I have for this video, guys. If you like this video and you learned some new things, give me a like. I really appreciate it. If you have any questions, if I didn't explain something very well, please ask it in the comments. I'd be more than happy to address your questions. Or if you thought this was a cool vid, just say it in the comments section as well. I appreciate the, you know, the praise or whatever. That'd be nice to hear. If you enjoyed this video and you want to see more of this type of content, don't forget to subscribe and hit the bell icon so you're notified when new content drops. I will see you guys in the next one. Peace out.